what is the relation between the abstract world of mathematics and the concrete world of our everyday life? That I try to find out, because there is this position in even among mathematicians. I think that some mathematicians, they have a vision, we'll say a vision of an engineer. So for them, mathematics is just an instrument to measure what is already here around them and what is seen, etc. And you have mathematicians like yourself, where it's actually the truth. Yeah. Mathematics is the truth. And so what we see around is not really the truth. It's what I was referring to when I was comparing you to Plato or something. Say you are very much into this.
Well, there are mathematicians who feel comfortable with different levels of abstraction or different sizes of infinity, and it's sort of like each person chooses a vision of God if they believe in God. Different mathematicians have an intuition or want to work in or feel comfortable with different sizes of infinity. Some of us want to stop down below with the smallest infinity. That's my case, 0, 1, 2, 3, 4, 5, and algorithms as much as possible, because to me that seems more concrete and more real. But other mathematicians love continuous mathematics. They're beautiful theorems, beautiful subjects there, and on the face of it, that mathematics, was applied in physics very successfully up to a point. When you get to quantum mechanics, things start looking more discrete because of the particles. So,
but because we are talking about quantum mechanics, and we are talking about
which
mechanics,
no one understands, right?
Exactly, but doesn't matter. I mean, who understands it? I'm wondering even if physicists understand what they are actually saying. So I mean, understanding here is just
I think they're still grappling with the paradoxes of quantum mechanics, and they're finding more and more paradoxes,
of course,
such as convivial solipsism that Eversviern talks about.
Yes, exactly. But because we're talking about mathematics, so we are also talking about calculations. We are talking about all these kind of things. Quantum. What about quantum computers? So I know now quantum computers are not really ready to challenge regular computers, but that's not the point. The point is, do you think that regular computers compared to quantum computers, there is something related to infinity, like meaning quantum computers are closer to infinity or not?
Well, they would be much faster at some problems. I'm not sure, speaking as an engineer, I'm not sure if quantum, I get the feeling that people are backing off. Quantum cryptography seems to be a very successful technology, but I think people are backing off on promises to produce useful quantum computers. But you see, the notion of a quantum computer and qubits as theory is very powerful. It's very valuable as a reformulation of quantum mechanics in terms of information theory, quantum information qubits. So that's very valuable, in my opinion.
It's interesting because from the philosophy of science point of view, from epistemological point of view, it's quite interesting to see that when we are talking about quantum mechanics, it's pure, it's a coherent reasoning. Because what I'm saying is, as in analytical philosophy, they usually distinguish three ways to assert the truth, to validate the truth. It's what they call factualism. They make an experience and it's a fact. So I've met John, so I know John, but I know John, but do I know his DNA? But at least it's the experience. The second is pragmatism. I say, I know that because that works. So they call pragmatism. And coherentism. I know that because maybe that doesn't work. Maybe I haven't met the experience, but I know it must work because it's coherent. It has to work. I mean, it must work. And even if I haven't seen it, because it's coherent. And it's interesting because in the history of science, usually it's more factualism and pragmatism, and afterwards, like retroactively, we build a theory to say, oh yeah, of course, it's coherent. But with this quantum computer thing, people say, shit, that doesn't work. I mean, that doesn't work, and we don't need the fact, but it has to work. It must work because because the theory, I mean, coherently, it has to be more efficient, even if it is not right now. It's interesting, don't you think? So it's because we are obsessed with the fact that it must work that we wait for a breakthrough. Actually.
Yeah. Well, internal contradictions in physics, sometimes you get new physics from observations of a new phenomenon like electricity or electromagnetic waves. But sometimes it comes from a contradiction. Quantum mechanics actually does initially start from a contradiction. I believe there was the problem of the black body radiation, and according to I can't remember the detailed history, but you would get an ultraviolet explosion or something where you would get infinities, and I think this was part of what led Planck to quantize. What did he quantize? He quantized radiation in a black body, I believe. And then Einstein, it wasn't quite so obvious that he was quantizing things. With Einstein's analysis of the photoelectric effect, it became very clear that this was new physics, because Maxwell's equations are continuous, and all of a sudden Einstein started saying there are photons, there are particles of electromagnetism. So sometimes an internal contradiction is fertile. In other cases, people haven't figured out how to eliminate it. So other times it's observations. For example, there is the James Webb Telescope. It seems to be changing our understanding of the early universe, because it's seeing things that, according to our current understanding, shouldn't be there in the early universe, right? So that's very valuable because we can't imagine, nature's imagination is greater than ours. So you can't do science by pure thought. You have to, maybe a good theoretician pretends to do metaphysics, but you have to look at the physical world and see if it works or not.
Check it out.
To check it out, right. So.
Verify.
Yeah.
Verification. I think when we are talking about infinity, and when we are talking about abstract and concrete, we could say that the capacity abstraction is a capacity of the mind, right? The fact that we can have abstraction, because we even say I abstract myself. It's just like I have an abstraction. It's not the world we.
But it's not just abstraction. Mathematicians invent things.
Yes.
They invent new mathematical entities. They invent new fields of mathematics.
But you think those entities already existed and they found them, or it's something that they create while they are inventing it? So they discover or they invent? Is it a discovery or is it an invention?
That's a good question. Certainly, if you look at the history of mathematics, different fashions, the mathematics of 50 years ago or 100 years ago or 200 years ago looks very different from
because the discovery means they uncover something that is already there, say, oh yes, look, that's there.
Right. But maybe
it was already
it's
there.
more like, maybe it's a little more like being a novelist, Sometimes you get the feeling, what did Grothendieck said, these things are as if summoned from the void. I think
Chaos, the void.
Yeah, I think Grothendieck had a very powerful personality, and I think he created his way of doing mathematics. It was definitely, I think, a personal creation. That if he hadn't, it's like a great work of literature. If he hadn't created it, I don't think the math community would be doing mathematics the way Grothendieck did. Nobody else was capable of creating it. So it's like a great work of art also. So I don't know.
But if we admit that the mind, whatever it is right now, is able to discover or to invent,
It's a godlike ability to be
that
able
means
to
the
invent
mind is able
mathematical
to somehow not figure, I don't know how to find a word, infinity, because like Cantor or other mathematicians, yourself, were imagining infinity, were actually formalizing it.
Yeah, people denied infinity. Cantor was very brave. People said there is no actual infinity. Maybe Gauss said that. There's just an unlimited series that goes on forever, 1, 2, 3, 4, 5. But actual infinity, people said, doesn't exist. But Cantor showed that we can work with actual infinities, with infinite sets, with infinite numbers.
Yes.
And it works up to a point. If you push it too far, you get contradictions, though.
So the question...
So people got scared and pulled back.
Again,
partially.
they are scared because it's a dangerous...
Right. I don't think Cantor was scared because I think he actually was doing mathematical theology.
He was a hero of mathematics.
Well, he was a mathematical mystic, is maybe another way to put it.
Yeah, of course. So the question I wanted to raise, saying that the mind is able to formalize, to touch, to do something with infinity. So does that mean that the mind itself is infinite?
I think the mind has an infinite capacity to invent new ideas, new mathematics.
So the mind is not limited by the brain, because the brain is limited.
Well, each mathematician's life is limited, but...
So the mind goes beyond the brain. I don't know. I'm just asking because
Individual humans, we're finite, right? But I think that the spirit, the human spirit...
It's interesting because you're not using the mind anymore. You're saying spirit. That's interesting. So for you, the mind is the spirit. And that's... No, but I agree with that. I mean, I'm not denying that. I'm not, it's not contempt when I'm saying that. On the contrary, it's just that I feel you, I will say.
Right. You're making more precise words that I use without really knowing precisely what they mean.
I'm very careful when I'm listening to you.
You're much more careful than I am.
No, you are. You're also.
Words. Yeah, so the world of mathematical creativity, I think, is unlimited, really. That's my faith. I interpret Gödel, incompleteness, and even Turing's result on uncomputability to mean that there's always more mathematics than can be invented or discovered. I'm beginning to think, we fool ourselves into thinking that some mathematical discoveries are inevitable. So that means that we discover them. I'm beginning to think now, actually, that it's more an act of artistic creation, frankly. But we fool ourselves into thinking that it's inevitable and it's